Good morning, everyone. We were doing alternating current generator in the last class, AC generator, right? Okay, so I'll explain that point one more time because I was rushing towards the end in the last class. So I'll teach that topic one more time. Okay, so AC generator is what? AC generator. First of all, there are two types of current, AC and DC. DC means what? Direct current, right? Direct current. Okay, direct current means the voltage or current, if you draw, it will be above x-axis all the time. X-axis all the time. Positive values. Only positive values. Whereas alternating current, if you represent graphically, it will look like this with positive and negative half cycles. Okay. These are called positive and negative half cycles. Look at this. They'll come in succession like this. Plus, minus, like this. There will be positive values, negative values, positive values, negative values, positive values, negative values. This is alternating. Alternating means changing direction, changing polarity. Okay. So basically there are two types of current. Do not worry about this. You will see in the next chapter. All right. Okay. This is called direct current or DC, which always is positive. Got it. It always stays above x-axis. Positive values only. If it is positive 3 volts, positive 3, positive 3, positive 3, plus 3, plus 3, plus 3, plus 3, plus 3, everywhere it is plus 3. Steady value. Got it? This remote has a cell inside. The cell is 1.5 volts. All the time it is 1.5. Got it? It's a steady voltage. Got it? That is called a direct current. Okay. Whereas alternating current continuously changes polarity. Alternating current continuously changes polarity. Next chapter is about alternating currents. Okay. Positive, negative, likewise. Polarity changes continuously. Okay. Anyway, we are looking at AC generator here. AC generator. What does it do? It basically converts mechanical energy into electrical energy. For example, like I told you yesterday, if you have hydroelectric power stations, Niagara Falls have hydroelectric power stations, right? Hydro based on water. Okay, water will be stored. Water will propel a turbine. When turbine rotates, you will get electricity. Or wind energy. Windmills, huge windmills have mechanical energy converted to electrical energy. Got it? So basically, inside a generator, what happens? Mechanical energy is turning into electrical energy. You are getting electrical energy, that's it. Okay, how? Some sort of a motion, mechanical energy. Got it? You can use water, you can use steam, you can use wind or tide, low tide, high tide in oceans, no? Anything to propel a turbine. Or you can propel it by hand, which is practically not possible. Got it? Anyway, when you rotate a coil, you will get electricity, as simple as that. Got it? So, this is the basic setup. You know, we have a pair of pole pieces. One is north pole, south pole. This is called a field magnet. There will be a huge magnet called field magnet. Yesterday I told you about Hoover Dam and all. Three Gorges Dam and the armature coil, the field magnet. There will be huge magnets. Okay. Inside which a coil will be kept like this. There is a coil like this. Okay. At the end of the coil, there is a shaft. There is a rod like this. At the end of the shaft, there will be a fan-like structure called turbine. Correct. Turbine. Wind turbines. Okay. Then what? Water hits the turbine. Turbine will rotate. When the turbine rotates, the coil rotates. Correct. The coil rotates. So the coil is called armature coil. Armature coil. Yesterday I told you either the magnet or the coil will rotate. In some countries, coil rotates. In some other countries, magnet rotates. Okay. It is based on operational convenience. Okay. Some cases, rotor and stator. They are called rotor and stator. The one which is rotating is called rotor. The one which is stationary is called stator, even though the names are not mentioned in the reader anymore. These are not given in the reader, but just know that one of them is rotating, the other is staying at rest. Got it? So what happens when the coil rotates? Continuously, flux is changing, right? Flux is changing means an EMF will be developed. That is what Faraday says, right? According to Faraday, Whenever the flux changes, tell me Leslie, whenever the flux changes, an EMF is developed. Okay, whenever the flux changes, an EMF is developed. Okay, that is what Faraday says, right? So here, as you can see, somebody propels a turbine, somebody rotates the turbine. When the turbine rotates, the armature coil rotates. Armature coil rotates means the flux is changing because it is rotating where? Inside a magnet, right? Inside a magnet, right? Automatically, electricity will be generated. How will you take it out? There will be a ring connected to this. There will be a ring connected to this. They are called slip rings. Slip rings. They are given as contacts. You know, you will connect two brushes here. These are called graphite brushes. All right, the graphite brush will always touch the ring. Always touch the ring. And then what? From here you can take wires. Understood? So what happens now? Look at the sequence. Water or whatever you have, steam, water, air, wind, whatever it is, will hit the turbine. Turbine will rotate. The shaft rotates. Coil rotates. Flux is being cut. Electricity is generated, right? And that is coming out through this ring to the contact. All the time it is touching the contact, right? So there will be continuous flow of electricity. Got it? See this? Yesterday you saw this, but anyway, this is what it is. This is what it is. See this? Look at this. See the negative and south, north and south, the magnetic pole pieces. And right inside there is a coil that's turning, correct? And look at the green lines, they are flux lines, right? Flux lines are being intercepted, right? Flux lines are cut. And these are the slip rings. There are graphite brushes. Some teachers say carbon brushes. That's also fine. Because carbon and graphite are different forms of the same thing, right? Correct. Okay. And then electricity is taken through the wire, which will power the bulb. See this? The bulb turns on and off continuously, right? Okay. Okay. Right. So this is how it works. And I wanted to show you something I forgot yesterday. This is the electromagnetic induction, concept of electromagnetic induction I told you. We have the coil here.
When you connect the coil with a supply, it starts converting electric energy into magnetic field. Now let's take a different case. When a magnet is suddenly put near to the coil, an EMF rises at the ends of the coil. But this EMF will disappear as our magnets stop moving. If we pull magnet in opposite direction, EMF will also start producing in opposite direction. For producing EMF continuously, we have to keep our magnet.
Polarity change, right?
It is called electromagnetic induction. This phenomenon is used in countless applications. Like the video, and don't forget to hit the subscribe button.
Polarity changes like 50 times. We are putting it in 50 times per second. Instead of putting it and taking it out, you can just let it rotate. Got it? See, is it possible to put it and take it out all the time? Instead, take a rotational motion. It will have the same effect. Got it? So anyway, this is what it is. You know, mechanical energy is converted to electrical energy. The components are armature coil, field magnet, slip rings and graphite brushes. Slip rings and graphite brushes. Okay, graphite brushes. All right, graphite brushes. And as it continuously rotates, you are getting electricity. Let us have a mathematical treatment of this. Before I start, I need you to know two things. Number one, what is the equation for flux? Flux is given by BA cos theta. Do you remember this? Do you remember this? I'll start from the beginning, don't worry. So flux is given by B dot A. This is the definition of mathematical definition of flux. Phi is given by B dot A. Phi is given by B dot A. That is equal to B into A into cos of theta. If there are n windings, that will be NBA cos theta. Okay, NBA cos theta. All right. This is the first thing. Second thing, I'll tell you, omega is written as theta by T. Do you remember having seen something like this? Forget about that. Do you know what velocity is? Velocity is given by displacement by time. Am I correct? You learned this in class 8. Yes. Velocity is equal to displacement by time, or speed is equal to distance by time. Similar way, angular velocity is equal to angular displacement by time. If something rotates, how do you find the angular velocity? The angle covered divided by time taken for it. Okay, you learned this in first year classes. I repeat, this is in linear motion. Linear velocity is equal to, for example, this is you. You are traveling and the distance traveled is x. How do you find your velocity? The linear displacement divided by time. Okay. Okay. On the other hand, you traveled in a circle. Imagine you were here. Now you are here. What is the angle covered by you? Theta. Understood? Divided by time taken for it. That is called angular velocity. Okay. So let us not make things complicated. Just know this, because what I want is the mathematical part. Theta is called what? Cross multiply. Omega t, right? Omega t, right? So I have like theta is equal to omega t. So NBA cos omega t. This is the first thing we have to know. Flux is given by NBA cos omega t. Second thing you have to learn by heart, particularly if you haven't chosen mathematics. I'll tell you d by dt of cos t is equal to minus sin t. D by dt of cos t, derivative of cos t is minus sin t, derivative of cos t is minus sin t. So d by dt of cos omega t will be, there is an extra omega here, right? So you have to write minus sin omega t into that extra omega you have to put. I repeat one more time. Look at this. Look at this. You know, first thing is what? Flux is given by B dot A. It is not complicated. B dot A, which is BA cos theta. What is B? Magnetic field. Stay pleasant. Magnetic field. What is A? Area. Theta is angle covered by the coil. Coil is continuously rotating, isn't it? Coil is continuously rotating, right? So it is covering angles, right? Correct. Correct. The angle covered is theta. How to get it? Omega into time. Then second thing is d by dt of cos t. It is there in the log book. D by dt of cos t. Derivative of cos is minus sine. D by dt of cos t is minus sine t. What is d by dt of cos omega t? There is an extra omega, right? When there is an extra omega, you put that extra omega outside also. This is called chain rule in mathematics. Minus sine omega t into omega. Let me do this now. What is the equation for EMF? By Lenz's law, I told you that EMF is given by minus d phi by dt. Do you remember this? Lenz's law is what? EMF generated by change of flux is equal to minus d by dt of phi. It's a 3-mark question, very important one. So many times it has come minus d by dt of, what is phi? Phi is here. What is it? NBA cos omega t. Let us take the constants out. Tell me, Bilal. Minus n comes out. Yes. B comes out. A comes out, right? What is inside Amsha? D by dt of, tell me, cos omega t. Cos omega t. D by dt of cos omega t is what? I've written here minus sin omega t into omega, right? So that's where I stop. Minus NBA into. This is written there. Minus sin omega t into omega. Last step, minus or minus plus. NBA omega sin omega t. Finished. Sin omega t. N is a constant, number of turns, right? Number of turns on the coil. B is magnetic field, constant. A is area, constant. Omega, angular velocity, constant. So if all these are constants, they are together going to be called E0. All are constants now. So you can take them together as another constant. E0 sin omega t. This is where we start the next chapter, alternating currents. This is the first equation of chapter alternating currents. Got it? E is equal to, this voltage is called alternating voltage. E is equal to E0 sin omega t. The general equation for the equation for voltage you're getting is E is equal to E0 sin omega t. E is equal to E0 sin omega t. I'll explain how I got this one more time. It's a 3-mark question. So many times it has appeared in examinations. Okay. And let me ask you one more thing. Look at this. Yesterday I told you, look at this. Imagine there is a north pole. There is a south pole here. North pole and south pole. So the field line is going this way. Got it? The coil is held this way. What is angle now? This is area vector, okay? Where is field going? Field lines are going from there to there, okay? Field lines are going in this direction. Just imagine lines in front of my eyes, okay? Then I'm holding the coil like this. Area vector is this. Area vector is always perpendicular to the surface. Correct. Theta is what now? 0. Because field line is in this direction. Area vector is also in this direction. Now what is theta? 90. Now what is theta? 180. Now what is theta? 270. Now what is theta? 360. So when the coil turns through 0 to 360, you know, it is called one complete rotation. Got it? So basically, look at this. The coil is initially at 0, now at 90, now 180, now 270, 360. Got it? That is one cycle. Again, second cycle, 90, 180, 270, 360. 90, 180, 270, 360. Similar way, in India, every generator rotates how many times? Yesterday I said 50 times in a second, 50 times. That is why we say in India, frequency is 50 hertz. In US, it is 60 hertz. Japan, it is 100 hertz. Got it? Frequency is basically the number of rotations that the generator makes. E is equal to E0 sin omega t. Look at this. My general equation is E is equal to E0 sin omega t. I'll ask one of you to on board. Listen to me. Okay. I'm taking all the cases. Okay. Omega t is equal to 0. First angle was 0, right? I said theta 0, theta 90, theta 180, theta 270, theta 360, right? Oh, no. Look at this. Theta 0, theta 90, theta 180, theta 270, theta 360. I'm going to write all those cases. Just watch me doing this. Omega t is equal to 0. E is equal to E0 sin omega t 0. Na? Sin 0 is equal to 0. Got it? Next one. Don't do it now, Aryan. Omega t is equal to 90. I am doing 90. What is it? E is equal to E0 sin 90. Sin 90 is 1. Sin 90 is 1. So that is equal to E0. Then omega t is equal to 180. E is equal to E0 sin 180. Sin 180 is minus 1. Minus 1 into E0 minus E0. Next is what? Omega t is equal to 270. Tell me, Namisha. E is equal to E0 sin 270. I'll tell you the value. Sin 270 is equal to, sin 270 is equal to 0. Sorry, sin 270 will be sin, that is equal to 0. Now omega t is equal to 360. 360 will be E is equal to E0 sin 360. Sin 360 is, oh, this will be, just give me a second. 0 is 0. Oh, this is sin 180 0. I made a mistake, sorry. Sin 180 0. And this will be minus E0 and this will be E0 into sin 0, that is equal to 0. Don't worry about the values. I'll tell you something. See this, Johan. I'm going to draw the graph. Omega t here, A here. What is our first location? What is the first location? 0, 0. Where is it? 0, 0 is right here, okay? Correct. Next is what? 90, E0. At 90, E0. This is called E0. Okay. Next is what? 180, 0. At 180, it is 0. Next is what? 270. At 2, this is 270. 270. At 270, it is what? 270, it is minus E0. At 360, it is 0. If you connect them through a smooth curve, that is what you get. This is the sine curve. Sine curve. If you learn that in mathematics, even otherwise, I just put the values. 0, 0, 90 E0, 180 0, 270 minus 0, and 360 0. Don't worry, I'll do that again. I'll plot the graph again one more time. Look at this. Let me do that one more time from the beginning. This is what it is. AC generator. AC generator is what? Something that generates AC. AC means alternating current. DC has a problem. DC cannot be transmitted to long distances. Got it? You cannot store voltage over a long time also. It's very difficult. So AC has its own advantages. That is why, you know, for example, in Qatar, they generate electricity somewhere there. maybe in Alcor, and they take electricity to different places of Qatar, locations of Qatar. Got it. It is actually distribution is done as alternating current. Alternating current. What is alternating current? DC is direct current. Direct current means all the time it is positive. It does not change direction. It does not change. Tell me, it does not change direction. It does not vary. It stays the same. It is a constant voltage, positive all the time. Got it? Whereas alternating current, alternating means changing. Changing what? Changing polarity. Plus minus, plus minus, plus minus, plus minus continuously. Got it? So AC generator does what? Converts mechanical energy into electrical energy. This is a previous board question. It converts what into what? Timothy, mechanical energy into electrical energy. What are the components of this? Slip rings, graphite brushes, the armature coil, field magnet. Field magnet, armature coil, slip rings, graphite brushes. Okay. Either the magnet or the coil will rotate, keeping the other at rest. Got it? Either the magnet or the coil will rotate with respect to the other. Sometimes the magnet will rotate or the coil will rotate. Got it? When the coil rotates, the electricity is taken through the fiber. Okay, the wire. All right. And how do you get the general form of AC? I'm doing this one more time. Look at this. This is how we do it. First is what? First, I am writing the equation for EMF. EMF is given by what? Minus d phi by dt. Then I think about phi. What is the equation for phi? To hand. Phi is equal to, phi is in fact B dot A. B dot A. Flux is given by B dot A. Okay. That is equal to B A cos theta. In n turns, if there are n turns, that must be n B A cos theta. Correct? N B A cos theta. I'm making a change. Look at this. Linear velocity is linear displacement by time. Linear velocity is straight line velocity is straight line displacement by time. Angular velocity is what? Angular displacement by time. For example, if you want to find the velocity of the needle of your watch, it's angular velocity you're talking about. It's rotational motion, right? Correct. So angular velocity is angular displacement by time. Cross multiply, theta can be written as omega t. So you get what? N B A cos omega t. This is the equation for flux. Okay. And one thing I told you, d by dt of sine t, d by dt of cos t is, sine t is, cos t is what? D by dt of cos t is, I told you there is a standard formula for it, minus sine of t. Correct. D by dt of cos t is minus sine t. So d by dt of cos omega t is what? Cos omega t is minus sine omega t. And there is an extra omega, right? So you have to put an extra omega. That is called chain rule or function of a function rule. Got it? Then I can complete this. That is equal to minus d by dt of, what is phi? Phi is written there. N B A cos omega t. Then I take the common constants together outside. N comes out. Correct. B comes out. A is also getting out, right? Tell me what you have. Don't sleep. D by dt of cos omega t inside. Okay. D by dt of cos omega t. Am I correct? And what is this? Minus N B A into, what is d by dt of cos omega t? Minus sine omega t. Very good. Minus sine omega t into omega. So minus of minus will be plus N B A omega. I write this omega first. Don't take this omega into omega square. Okay. That is actually argument of sine. Sine. That is with the sine. Sine is like writing sine 90. Okay. That omega comes with this guy. Okay. NAB omega into sine omega t. Finally, I call what? All these guys together as E0. E0 sine omega t. So this is called the general form of alternating current. E is equal to E0 sine omega t. Now let us plot this graphically. That's also a previous question. It's given in the reader. Yesterday I showed the graph, but it is not clearly visible. I'm just drawing it myself. Look at this. I'm writing my equation. E is equal to, tell me, E0 sine omega t. So let us take the first angle. Omega t is equal to 0. Tell me what you get. E is equal to E0 into, yes, sine 0. Sine 0, 0. Sine 0 is 0. Got it? Second is what? Tell me, Elijah. Omega t is 90. So E will be E0 sine 90. Sine 90 is 1. Second angle is 90, no? Sine 90 is 1. Correct. Third is what? Omega t is equal to 180. Tell me about it, Timothy. E is equal to E0 sine 180. Sine 180 will be 0. So that is 0. Got it. Fourth is what? Omega t is equal to 270. So E will be equal to E0 sine 270. That will be minus E0 because sine 270 is minus 1. Sine 270 is minus 1. Minus E0. Omega t is equal to 360. E is equal to E0 sine 360. That is equal to 0. I'll draw the graph now. See what I'm drawing? Look at this. It's very simple now. I'm drawing. This is my 90. This is 180. This is 270. This is 360. Okay. Okay. This is E0 and this is minus E0. Where is the first point? You tell me where is the first point? First point is 0, 0. Right. Correct. 0, 0 is right here, right? Origin. Second point is where? Second point is where? 90, E0. Am I correct? Tell me, please. I'm asking you. 90, E0. This is that point. Am I correct? Correct. Third one is what? 180, 0. Tell me what you can get. 180, 0. This is 180, 0. Right. 180 and 0. Right. And next is 270, minus E0. Where is it? 270 minus E0. Right here, right? Correct? Correct. Last is 360, 0. 360, 0. 360, 0 is right here. Now just connect those dots by a free curve like this. This is called sinusoidal graph. Sinusoidal or sinusoidal. Some teachers say sinusoidal or sinusoidal is also fine. It's a graph of sine function. Graph of sine theta. Understood? In large scale power generation, electricity is generated as per which equation? E is equal to E0 sine omega t. Understood? Have you heard about inverters? Your computer has a backup, right? UPS. Backup battery, no? Yes. Inverter you don't have. When here you don't have power cut. But back in India, when you have power outage, you use the inverter. What will you do there? There actually during the daytime, when there is power, battery will be charged. The inverter has a battery. And when the power is gone, that will be converted back to AC. Inside battery, it will be DC, right? It will be stored as DC. Got it? Oh no. Imagine now we have current. Okay. Now we have power supply. You will connect the inverter to the power supply. What will happen? Inverter will keep getting charged. It is a battery. Got it? It's like a power bank. Got it? So it is stored as what? DC only, DC. But you know, when you take it out, when there is power cut, when there is power outage, you do what? You have to take it back, right? But your devices are working on AC, right? You have to convert it to AC. But the problem is, when you convert it to AC, you won't get a perfect sine wave. Understood? In India, we don't manufacture perfect sine wave inverters. So it's almost like this curve. It's not perfect. That is why if you use inverters for a long time, your devices get damaged. Understood? There are pure sine wave German inverters. German inverters are high, very good in quality. Understood? They have perfect sine wave inverters. So when you buy inverters, you just see this word. You might see this pure sine wave inverter. Pure sine wave, because it's sine wave. Understood? You have to get the AC of actual form. Got it? Got it? Right. So let us start writing. All of you online understood this? Graph starts from 0. Right, AC generator. You can write generates alternating current. AC generator generates alternating current. Alternating current. Okay. On the side, on the margin, you can draw this. This is alternating current. Alternates. Alternate means change polarity. Change polarity means Plus and minus, they come continuously. Got it? This is positive. This is negative. Do you understand? Understand? That's called positive half cycle. This is called negative half cycle, about which we will learn later in the next chapter. Okay. Okay. For a DC, it's all the time positive. AC, it continuously keeps changing. Got it? Okay. An AC generator generates alternating current. Okay. Next one, converts mechanical energy. The statement is there in the reader. Converts mechanical energy into electrical energy. Converts mechanical energy into electrical energy. Generates alternating current. It converts mechanical energy into electrical energy. All right. Some sort of a rotation turns into electricity. Some sort of a movement converts into electricity. Got it? Okay. Converts mechanical energy into electrical energy. Components. Components. I'm really bad at drawing, so I'm not trying to draw the figure. You can take it from the textbook. Okay. Okay. Do you want to see the figure? This, oh, not this one. This is the figure. This is the graph. Okay. This is how it would look like. You have to draw this somehow. You have to draw this somehow. Okay. North pole, south pole, armature coil, graphite brushes, slip rings. Got it? This is the figure you have to draw. All right. I have to draw. A rough figure would do. Okay. No problem. Right. So this is what components you can write. First is armature coil. In actual power stations, coils will be so huge, enormously large. Okay. It will have the size of this building. Right. Yesterday I told you. Armature coil. Next is field magnets. Armature coil, field magnets, slip rings. Slip rings are those rings. Okay. Graphite brushes. Graphite or carbon. In school examination, write whatever your teacher has said. Graphite or carbon. Graphite brushes. Armature coil, field magnets, slip rings, graphite brushes. Armature coil, field magnets, slip rings, graphite brushes. Okay. I'll try a rough figure anyway. Right. North pole and south pole. That's it. You've drawn the same thing in class 10 also. AC generator you learned. Seeing your face, it seems you haven't seen it at all. Haven't you learned this? It was deleted. Okay. Armature coil, field magnets, slip rings, graphite brushes. Armature coil, field magnets, slip rings, graphite brushes. The components are armature coil, field magnets, slip rings, and graphite brushes. Okay. So let us write working. Working. The armature coil is the armature coil is made to rotate. The armature coil is made, M-A-D-E. The armature coil is made to rotate. The armature coil is made to rotate. The armature coil is made to rotate continuously. The armature coil is made to rotate continuously inside the magnetic field. The armature coil is made to rotate The armature coil is made to rotate inside the magnetic field. The armature coil is made to rotate inside the magnetic field continuously. Okay, the armature coil is made to rotate inside the magnetic field continuously. Okay, full stop. Due to continuous change of flux, continuous rotation means continuous change of flux, correct? Due to continuous change of flux, an EMF is induced in the coil. Due to continuous change of flux, FLUX, due to continuous change of flux, an EMF is induced in the coil. Due to continuous change of flux, an EMF is induced in the coil. Okay. Okay, which means electricity is generated. Correct. The electricity is taken out. Electricity is taken out with the help of due to the continuous change of flux, an EMF is induced in the coil. Okay. Then what we write? Next. Electricity is taken out with the help of slip rings and graphite brushes. Slip rings and graphite brushes. Slip rings and graphite brushes. Slip rings, SLIP, slip rings and graphite brushes. Okay. Right. Next line, you write this on the margin. Flux is what? Do you remember what I said? Flux is what? N B dot A, right? One turn it is B dot A. Two turns, 2B dot A. Three turns, 3B dot A. N turns, NB dot A. As simple as that. That is equal to, tell me what? N B dot A is B A cos theta. Correct. That is equal to N B A cos omega t. If you want to know how, you must write omega is equal to theta by t. Omega is equal to theta by t. On the margin, omega is equal to theta by t. Cross multiply. Cross multiply, what do we get? Theta is equal to omega t. Correct. And write one more thing, d by dt of sin t is equal to, or d by dt of cos t. D by dt of cos t is equal to, yes, minus sin t. D by dt of cos omega t is minus sin omega t into omega. Minus sin omega t into omega. Let's put it back here. Minus d by dt of, what is phi? N B A cos omega t. So get the constants outside. N comes outside, B comes outside, A also comes outside. Okay. D by dt of, what is inside? D by dt of cos omega t. Correct. One last step, minus N B A. What is d by dt of cos omega t? Minus sin omega t into omega. take these guys together. Okay. What is it going to be? Minus of minus plus NBA omega into sine omega t is equal to, I'll call these together. N is the number of turns, B is the magnetic field strength, A is the area, omega is the angular velocity, sine omega t is equal to E0 sine omega t. This is the general form of, it's a 5-mark question, okay? They'll ask from the beginning, AC, what is generator, then the components, working, then all these things. Got it? And the graph. Multiple times asked, you check the previous papers if I'm lying. Okay. So how many times asked? Such a simple question. All right. One more question came once in examination. I'll do that now. Numerical. E0 sin omega t. You finished here? All of you finished, everyone? Okay. Now let us draw the graph also. Right. Omega t is equal to, first number is, first angle is 0. See this again. One last time. That is a north pole. Look at me, everyone look at me. That is north pole, this is south pole. So the lines are going this way. Got it? I'm holding the coil this way, perpendicular to it. So area vector is perpendicular, right? What is theta? 0. Theta is 0 now. Correct? Field line is in this direction. Area vector is in this direction. Theta is 0. Now what? Area vector is towards you. So theta will be 90. Now one more 90, it is 180. One more 90, it is 270. Again 90, it is 360. 360 will be counted as 0 again. 0, you are back through one circle, right? Again 90, 180, 270, 360. 90, 180, 270, 360. 90, 180, 2, like that. Understood? That is continuously giving you electricity now. That's it. Got it? Look at my face and tell me. Right. Okay. Now write. Omega t is equal to 0. E will be what? E0 sine 0. Sine 0, 0. Omega t is equal to 90. Your teacher might write pi by 2. Don't worry. 90 is also written as pi by 2. Okay. 100% sure they will do this in your school. Okay. E is equal to E0 sine 90. That's going to be E0. Omega t is equal to 180 is equal to E0 sine 180. Sine 180 is sine 0, 0. Omega t is equal to 270 is equal to E0 sine 270. Sine 270 value, if you don't know, you must write minus 1. So it's minus E0. Minus E0. Next is omega t is equal to 360 is equal to E0 sine 360. Sine 360 is 0. Okay. Okay. So when it has gone through one full cycle, you got too many locations, right? Coordinates. Let us plot them. Take omega t on the y-axis and EMF on the y-axis. This location may be called E0. This location may be called minus E0. This is 0, 90, 180, 270, 360. First location is what? Let us mark the locations, okay? First location is circle this, 0, 0. Correct. Where is 0, 0? Right at the origin, right? Correct. Next is 90 and E0. 90, E0, right? From 90, go up until E0. This is that location. Correct. Third is 180, 0. Okay. 180 right here. Next is 270, minus E0. Minus E0 is here. Next is 360, 0. That's here. You have like 6 points now. You can connect them to plot the graph, right? Draw a free curve now. Do freehand drawing, okay? Continuous curve. It's a continuous curve. This is called sinusoidal graph. Okay, sinusoidal graph, sine curve. This is the graph for alternating current, sinusoidal form of alternating current. All of you understood this? Is it? Okay, so this is what it is. AC generator. AC generator is something that generates electricity. What kind of electricity? Alternating current, right? Okay, converts mechanical energy into electrical energy. Okay, and then there are components: armature coil, field magnets, slip rings, and graphite brushes. All right, and how is the working? Water falls on the turbine. The coil will rotate. Where does the coil rotate? Inside the magnetic field, right? So it is continuously changing the flux, creating an EMF. Okay, and voltage is developed. Electricity is taken through a pair of carbon brushes or graphite brushes and slip rings. Okay, and then I told you this EMF is given by minus d phi by dt. Phi is equal to NB dot A, that is NBA cos theta, because B dot A is BA cos theta. And again, omega is equal to theta by t. If you cross multiply, theta is equal to omega t. Okay, angular velocity is equal to angular displacement divided by time. So if you put it back here, NBA cos omega t. And again, d by dt of cos t, that's a standard mathematical formula, minus sin t. D by dt of cos omega t is what? Minus sin omega t into omega. That extra omega has to be put one more time. Okay, so I'm coming over here, minus d by dt of NBA cos omega t, NBA into d by dt of cos omega t, because NBA being constants will be taken outside. Okay, d by dt of cos omega t, I've got it over here, minus sin omega t into omega. So minus or minus plus NBA omega sin omega t. N is a constant, B is a constant, A is a constant, omega is a constant. Number of turns, magnetic field strength, area of the coil, angular velocity. All of them together will be called E0, maximum value of EMF. We will see that later. E is equal to E0 sin omega t is the equation for general form of AC. Okay, alternating current. Then the graph. You put the angles theta 0, 90, 180, 270, 360. Theta 0, E will be 0. Theta 90, E will be E0. Theta 180, E will be 0. Theta 270, E will be minus E0. Theta 360, E will be 0. This is 0, 0. Then 90, E0. 180, 0. 270 minus E0. 360, 0. So you connect them by a curve. That curve is going to be called sinusoidal form. Got it? Okay. One small point here. Write the question. Derive. Write a question. Derive. As such, it is deleted, but it still has a chance of coming. Okay, it's a 5-mark question. Derive the expression for energy stored in an inductor. 100% sure you won't lose even half mark from this chapter. I promise. Derive an expression for, just follow whatever I teach you. Derive an expression for energy stored in an inductor. Derive an expression for energy stored in an inductor. Energy stored in an inductor. Okay, close your book. Listen here. Look at this. Okay, so I have an inductor. This is an inductor. All right. You connect a cell, you connect a switch. Over the last couple of sessions, I have said 1,000 times what's happening here. When you switch it on, tell me, when you switch it on, current increases, field increases, flux increases, EMF is developed. Correct. Switch it off, current decreases, field decreases, flux decreases, EMF is developed. Okay. And that EMF was written as minus L into di by dt. Am I correct? EMF is equal to minus L into di by dt. Am I correct? All right. So just imagine this is EMF, and I'll tell you an easy method to do this. Just give me a second. Okay, right. So let us forget about that. So I'm just writing, look at this. I'm giving an EMF E here, and this is minus L into di by dt. The back EMF is minus L into di by dt. I told you yesterday, back EMF is minus L into di by dt. I'm applying Kirchhoff's rule, voltage rule. Kirchhoff's voltage rule is what? I'm walking to the right. First thing I see is minus L into di by dt. Then I keep walking, keep walking, keep walking, keep walking. I stop, negative of the cell. Negative of the cell means plus E is equal to 0. Correct? Nothing. I've just taken loop rule over here. That's it. Don't you remember loop rule? Nothing. You write down all the EMFs. That's it. What is the first EMF? Minus L into di by dt. That is called back EMF, right? Then I keep coming. Then it is negative. So it is plus C is equal to 0. Let me complete this. I'll explain again. Don't worry. E is equal to, this will go to the right side, plus L into di by dt. One last step. EMF's definition, do you remember? Work done per charge is called EMF. Work done to move a plus 1 coulomb from infinity up to the point. Do you remember? Nothing. EMF's definition is in fact W divided by Q. Almost all chapters, electricity chapters, have application of this equation. There we learned it in potential, electric potential, W by Q, or rather dW by dQ, because charge is continuously flowing. So you must take differential amounts, small quantity. dW is what? Small work done. dQ is what? Small amount of charge, because charge is given in small amounts. Charge is flowing in small amounts. So I'm writing this E as dW by dQ is equal to L into di by dt. Last step, dW is equal to, cross multiply. Tell me what you get. L into, tell me, di into dQ goes here, okay? Already dt is there, right? So dQ divided by dt. So dW is equal to L into dQ by dt is called I, current, into di. This is the small work done, right? If you know the small work done, how to find the total work done? How do you find the mass of Pacific Ocean? Take a cup of water, find its mass, integrate it over the volume, right? Same way, once you have got the small work done, total work done is given by integral L I di. Current is flowing from 0. Initial current is 0. Final current, I can call it I, or I0, whatever it is. Okay. That is equal to, I'm integrating. L comes outside. What is the integral of I raised to 1? It is I raised to 1. Integral of x raised to 7 dx is x raised to 7 plus 1 by 7 plus 1. I have told you 100,000 times. So integral of I raised to 1 di is what? I raised to 1 plus 1 by 1 plus 1. I square by 2. Understood? You can give the upper limit and lower limit is 0. There is no point in giving. Got it? This work is stored as energy inside the inductor. So energy inside the inductor is half L I square. Similar to half CV square in electrostatics. Capacitor. Energy stored in a capacitor. That derivation is no more there in syllabus, but equation is there, half CV square. Energy stored in a capacitor. Similar way, energy stored in an inductor is given by half L I square. Trust me, this is so important for examinations. Okay. And in your school, they'll definitely put this on papers. Okay. You'll see this at least one time this year. Right. So we'll write this. I'll explain one more time. We'll take a short break. Okay. Right. Draw the figure first. Draw the figure. Let us draw. I'll explain as we do. This is called an inductor. Okay. All of you online understood this? Somebody please ask me to repeat if you didn't understand. Okay, Dia. Rest of the guys understood or not? Inductor, right? Inductor is connected to a cell and a switch. And you remember the sequence? When you switch it on, current increases, field increases, flux increases, EMF is developed. Did you hear me? Current increases, field increases, flux increases, EMF is developed. Switch it off, current decreases. Tell me, Kirtana, field decreases, flux decreases, EMF is developed. Right. That EMF is called self-induced EMF. We learned it the other day. Minus L into di by dt. So, the back EMF here is minus L into di by dt. And the EMF applied is E. Okay? Okay. Right? Consider an inductor. Consider an inductor. Consider an inductor. Consider an inductor. Inductor. Inductor is another term for coil. Okay. Solenoid. Consider an inductor connected to. Consider an inductor connected to. This is the inductor. Look at this.
This is a simple coil.
This one. This is inductor. Okay. A coil. That's it. Consider an inductor connected to a cell and a switch as shown. Always, Iba. Consider an inductor. Ilhan, people. Consider an inductor connected to a cell and switch as shown. Okay. Full stop. The self-induced EMF is self-induced EMF is minus L into di by dt. Self-induced EMF is minus L into di by dt. Okay. Minus L into di by dt. Okay. Next line. Applying KVL. KVL means what? Kirchhoff's voltage law. Kirchhoff's voltage law. Applying KVL. Say Sesha. Applying KVL. You can start going from A. Okay. Write down equations, write down terms as you go. That's it. Go to the right. What is the first thing you see? Minus L into, I'm asking, di by dt. Then keep going. Then what do you see? Plus EMF. Then you are back at a 0. All right, Sesha. This is minus L into di by dt. Then plus C equal to 0. Correct? Correct. Okay. Now what? Get this to the right hand side. E is equal to plus L into di by dt. Okay. On the margin, write the definition of EMF. Original definition of EMF is work done per charge, W by Q. We have written this so many times, W by Q. But here I am attaching, prefixing D. Why? Because it's small amount of work. Small amount of work for small dispersal of charge, right? Small charge, right? Okay, charge is actually flowing in small amounts. That is why I'm thinking of taking small values. When you prefix a D to something, you are making it very small. Got it? Q means charge, dq means small charge. X means displacement, dx means small displacement. L means length, dl means small length. Got it? So it is small charge and small work. So cross multiply there. Cross multiply. Sorry. You can write this straight away. EMF can be replaced with dw over dq is equal to L into di by dt. Then get this dq to right hand side. dw is equal to L into, I take this dq there, okay? And I prefer to write dt under dq. dq goes there, dq by dt, right? Correct? Correct. Into, what else is there? di. I repeat, I'm keeping dw alone here, dq goes there, right? L is already there, dq goes there, dq by dt into di. Correct? This is the small work done. One more time. dW is equal to L into, what is dW by dt called? dQ by dt called? Do you remember from current electricity? dQ by dt is called I di. dQ by dt, this yellow circle is called, yellow bracket, dQ by dt is called I. Okay, current. Therefore, total work done. When you know the small work done, the process to find the total work done is integration. So, total work done W is equal to integral 0 to I0. Initial current is 0. Initially, when I switched it on, there was no current, right? And current went up to the maximum, I0. Correct. 0 to I0, L, I, D, I. Get that L outside. If you don't know, you must write somewhere integral I di on the margin. Integral I raised to 1 di is I square by 2. Integral of I raised to 1 is I raised to 1 plus 1 by 1 plus 1. Integral of I raised to 1 is I raised to 1 plus 1 by 1 plus 1. I raised to 2 by 2. Integral of I di is I square by 2. So put it back here. L into I square by 2. Lower limit 0, upper limit I0. Last step. Half L. I don't care to put the lower limit. It is 0 anyway, right? Just put the upper limit. See, first you have to put upper limit, then minus lower limit, right? But lower limit is not needed. 0. So only upper limit will do. Li0 square. This work is stored as energy, right? This work is stored as energy. So our question was to find an expression for energy. It's a 5-mark question. There will be a sub question also. Okay. Therefore, energy stored. I got the work done. Therefore, energy stored is half L I0 square. Understood this, all of you? So hope this is clear. First you take this inductor, applied EMF is E and the back EMF is minus L into di by dt, and you are applying Kirchhoff's voltage law, minus L into di by dt plus E is equal to 0. Get this to the right hand side, E is equal to plus L into di by dt, and EMF is written as dW by dQ, which is L into di by dt. Cross multiply, dW is equal to L into dQ by dt into di. dQ by dt is called I, current, isn't it? So Li di, this is the small work done for a small charge of dQ. Got it? So in order to find the total work done, you must integrate. Initial current is 0 because you are starting off from switching off. Correct? And then current grows to become maximum, I0. So 0 to I0 Li di, integration of I is I square by 2. That gives you half L I0 square. This work is stored as potential energy inside, magnetic energy inside the inductor, and it is half L I0 square. Got it? I'll do 2 questions from this chapter. Both are previous questions. And with that, the chapter is over. Okay. So write the question. Question number 1. Question number 1. Let us write question number 1. Write question number 1. Okay. Two identical loops. Write question number 1. 2 identical loops, L double of PS. 2 identical loops. One of copper. 2 identical loops. One of copper. One of copper and the other of aluminium. One of copper and the other of aluminium are rotated with two identical loops, one of copper and the other of aluminium, are rotated with same angular speed. I repeat, two identical loops, one of copper and the other of aluminium, are rotated with same angular speed in the same magnetic field. Okay. Mike has a problem, I think. Charge is not draining.
Please send the worksheet to this chapter.
Yeah, I'll send one more. Praveen, can you guys just take on the mic? Can you hear me now? Okay. Okay. Two identical loops, one of copper and the other of aluminium. Two identical loops, one of copper and aluminium, the other of aluminium, are rotated with same angular speed in the same magnetic field. I can repeat one more time. Two identical loops, two coils, okay? One is made of copper and the other of aluminium, are rotated with same angular speed in the same magnetic field. Compare number one, induced EMF. Number two, current produced in the coils. Justify your answer. Previous 4 paper question. There the worksheet, question number 18 and 19, worksheet questions. Okay. I repeat the question one last time. Two identical loops, one copper and the other of aluminium. One of copper and the other of aluminium are rotated with same angular speed. Same angular speed. Underline that. Same angular speed in the same magnetic field. Underline that also. Same magnetic field. Compare the induced EMF and current produced in the coils. Justify your answer. Okay. So look at this. Look at this. Look at this. First of all, I am writing for copper. EMF of copper. What is the equation for EMF? Do you remember the equation for EMF I got? The coil N A, tell me what? B omega sine omega t. Am I correct? Just now I told you this is nothing but a generator. Generator coil. I am talking about generator coil. Got it? You can apply the same equation here. Only thing is that you have only one coil. Instead of n turns, we have like one coil. Got it? Okay. So anyway, look at this. EMF is Na B omega sin omega t. What about copper coil? Number of turns for copper coil is 1. They haven't given the number, so let us presume it is 1. So 1 B A B omega sin omega t. This is for copper. What about for aluminium? Aluminium also has 1 turn, area same, because they say identical coils, right?
Yeah.
Area same. Magnetic field same, right? Given in the question.
Yeah.
Angular velocity same, right?
Yeah.
Given in the question. Sin omega t, that is also same. Omega is same, right?
Yeah.
So what do you understand? You can say E copper is equal to E aluminium. In both cases, the EMF generated will be the same. Understood? You don't have to justify because you have done this mathematically. So no justification is needed. Got it? So let us write from the beginning. You can write the first equation, write the first equation. EMF is given by write the EMF equation. EMF is given by, what is the equation for EMF? Everyone asking? Everyone understood? Please tell me in comments, everyone. EMF is given by, EMF equation is E0 sin omega t. Why do I use this equation? It is a coil. Whenever a coil rotates, the equation is E0 sin omega. Generator coil, we learned generator, right? Oh, don't tell me. EMF equation is what? E0 sin omega t. Okay. So E0 sin omega t. First you write for copper. First coil is made up of copper. Oh, E0 is in fact what? We better write the original form. N B A omega sin omega. This is the general form, original, right? Okay. Number of terms they haven't given. Okay. They haven't given, so I take it as one term. If not given, take it as one. Or keep it as n. Nothing wrong. Okay. A will be area. B is magnetic field. Omega is angular velocity. And sine of omega t. 1 AB omega sine omega t. All of you are only 2 people responded. Rest of the guys understood or not? Now E aluminium. Please don't leave. 5 people have already left. E aluminium. I know who have. All right. Right. E aluminium is equal to what? Aluminium number of turns is again 1. Area is what? They say that they are identical in all senses, right? Identical means they have same area, right? Look at the area, the shaded area. The shaded area of the coil is same in both cases, right? So area A. And in the question, they say magnetic field is same. Correct. Also, they say angular velocity is same, angular frequency. Then sine of omega t is also same. Therefore, compare them. What do you understand? E copper is equal to E aluminium. First part is solved. This is first part. Okay. Hope it's clear. Now, second part is about finding current. Write the current. Current equation is what? EMF by resistance. Do you remember this equation? This is called Ohm's law. Do you remember?
Yes.
You've been seeing since class 10. What is this?
Yeah.
E current is given by current. See, 5 more minutes actually. Please. Current is given by what? EMF divided by what to do? I'm telling the second session all the time. What to do? Current is given by EMF divided by resistance. EMF by resistance, right? So first you write I copper. I copper is equal to E divided by R copper. E is same for both, right? So I don't have to write E copper and E aluminium. Correct. E copper and E aluminium are same. Okay. I aluminium is equal to E divided by R aluminium. But one thing is clear, R copper is less than, very well less than R aluminium. Copper has less resistance in comparison with aluminium. Least resistance is for silver, then comes gold, then comes platinum, then comes copper. Okay, after that aluminium. If you compare copper and aluminium, who has less resistance? Copper has less resistance. All the connection wires here have copper wires, right? And copper threads inside, right? Why copper? Because we can't afford to use gold, right? Gold is much better, or even silver. Understood? Understood. So if you think in terms of resistance, best choice is silver or gold. Then comes copper, obviously. All the wires are made up of copper because copper has less resistance in comparison with aluminium. But in India, we still use aluminium because India is a third world country, right? We can't even afford to have copper. Understood? Right. So our copper is less than our aluminium. Our copper is less than our aluminium. So lesser the resistance, more is the current. So I copper is more than I aluminium. I copper is more than I aluminium. All of you understood? I'll give you one homework and minor. All of you understood this? The current part, if you didn't understand, please tell me, I can repeat. Nothing, current is given by what? One last time I'll tell you, current is given by voltage by resistance. This is called Ohm's law. 2 more minutes. I promise I won't go beyond that. Okay, current is given by EMF by resistance. Current is voltage divided by resistance. Voltage by resistance. Okay, and current in copper is EMF divided by resistance of copper. Current in aluminium is EMF divided by resistance of aluminium. Okay, but when you compare copper and aluminium, It is known that copper has less resistance. Resistance of copper is less than resistance of aluminium. Resistance of copper is less than resistance of aluminium. Okay, so lesser the value of resistance, more will be the value of current, because it is denominator, right? Inverse proportionality. Lesser the value, more will be this current. So current in copper is greater than current in aluminium. Understood? Current in copper is greater than current in aluminium. If they give silver, silver has much less resistance. Got it? Silver is in fact having the least resistance.
When it comes to
Than gold. Okay, right. So write one homework, remind it. Okay, write a homework question, previous question again. A coil of n turns, capital N. A coil of n turns. A coil of n turns, capital N. A coil of capital N turns. Area capital A. A coil of n turns, capital N turns. Area capital A. A coil of n turns. Area capital A is rotated at a coil of n turns, area capital A is rotated at constant angular speed. Constant, I have written here, angular speed omega. So also previous 4 paper question. Omega. In a uniform magnetic field B, in a uniform magnetic field B, in a uniform magnetic field B, and connected to a resistor R. In a uniform magnetic field B and connected to a resistor R. Deduce the expressions for deduce, derive. Deduce is derive. D-E-D-U-C. Deduce the expressions for deduce the expression for I said the solutions to these questions tonight, but try on your own. Deduce the expressions for 3 more questions. Deduce the expressions for number 1, maximum EMF induced in the coil, power dissipation in the coil. Maximum EMF induced in the coil, power dissipation in the coil. The chapter stands completed. Electromagnetic induction. Maximum EMF induced in the coil, power dissipation in the coil. Shall we write it for the day?